Welcome back, everyone. This is a high-reduction planetary gearbox that I designed in Fusion 360 and printed using my AnchorMake 3D printer. When tested, it works as expected, except for one thing. It is very noisy. Understanding the reduced noise benefits of belt and pulley setups, I considered the feasibility of developing a compounded reduction gear based on this system. This marked the start of my quest to create a compounded belt and pulley reduction gearbox. When the input is rotated by hand, the marker on the output shaft moves at a slower speed, showcasing the gearbox's reduction effect. In this project, I also developed a script for creating GT2 timing pulleys in Fusion 360, which will be the topic of a future video. I selected a GT2 timing belt and compatible timing pulleys for this design. You might be curious why I'm manually rotating this instead of using a motor. That's actually the crux of the title. The implementation hasn't gone as planned. The entire assembly isn't rotating as smoothly as I had hoped. The assembly, which I'm unable to present in animated form, is organized into two stages. Each stage is comprised of two smaller pulleys, one on the right and one on the left, alongside a larger central pulley. Although not depicted, each stage is matched with its own timing belt, thus forming two independent timing belt systems. The smaller pulleys on the right side of both stages are configured to rotate together on the same axis, and this synchronized rotation is also true for the smaller pulleys on the left. These pulleys are connected to the input pulley, which operates as the carrier. As the input, illustrated in a shade of red, turns, it drives the two sets of smaller pulleys to orbit around the central pulleys, while they also rotate on their axes. Within the central pulleys, one, indicated in orange, is stationary, while the other, shown in blue, is linked to the output shaft. The gear reduction is achieved by the output pulley having one more tooth than the stationary pulley. Before I delve into the compounded belt gearbox, I'd like to give you a brief overview of the planetary gearbox's contents. Essentially, the planetary gearbox is a two-stage system where the sun gear, planet gears, and ring gear for each stage are printed as a single unit. I apologize for the gearbox not being perfectly centered in the video. That's one of the challenges of operating solo. I'll disassemble the belt pulley reduction gearbox to take a closer look inside. As you can see, there are two timing belts. The bearing here allows for free rotation around the fixed pulley, which is typically mounted to the casing via this stationary shaft. This part is the housing for bearings. These bearings support the small pulleys on this side of the setup. One improvement I'd like to make in future iterations is adding a belt tensioning mechanism. There's also a bearing between the fixed and rotating pulley. I'm now going to disassemble the smaller pulley. As shown, they are made of individual parts that were assembled after printing. I anticipated a simple and straightforward design, but it turned out to be more challenging than expected. Although the video title indicates that it was almost successful, I consider it a success because it demonstrated that the engineering principles are sound and the design is functional. This design isn't intended for high torque applications. However, it may be appropriate for low to medium torque applications, depending on the type of belt used. It's also noteworthy that it is unlikely to be back drivable. Thank you for watching this video. Stay tuned for more content. If you enjoyed it, please support the channel by liking and subscribing. Share your thoughts or suggestions for improving this design in the comments below. And if you decide to adapt this design, I'd love to hear about your implementation. Share your experience.